So I just finished up with the last of the changes that I think I'm going to make to this just before I put it back together and fire it up. So I changed the diode block on this side with the old one, so that's back in place now. And I've made a couple modifications to the radio. The first one is I replaced this electrolytic here. This is a 5 volt at 5 microfarad at 64 volt. And I've replaced it with a 10 mic at, I think it's 200 volts. I just happen to have this. I didn't know I had this. I'm just changing this just purely because I don't trust the other capacitor. It's on the ratio detector, so it's, you know, if that thing changes, then that could affect the sensitivity, which could be what's causing my problems. Unlikely, but I changed it anyway. I don't think the value is too critical. Obviously, this is not the right value, but I think it's just for I think it's just a bypass cap, so I don't think it's too critical about the value. If there's issues with the performance, I can always order a proper one. It's just I don't have anything that's got that voltage rating on it. Unfortunately, it's rated for 64 volts, which is kind of weird. And while I was looking through my parts, I also managed to find a capacitor to go here. So this was the this was a 0.47 at 200, and it's a metallized foil. And I actually happen to have a another cap here. This is a 1600 volt 0.47. That doesn't matter. So I put that in there just for good measure. I mean, and at this point there is nothing else. There's no other types of capacitors other than the ceramics and the micas in this. So basically everything that's in here now is fully untestable, and I'm not going to mess with until I can prove something's wrong, because removing these kinds of caps and replacing them willy-nilly is not good, because they have specially engineered temp codes and stuff to drift with the coils and stuff. I mean, they're generally almost always good. So at this point, I'm just going to sort of leave it. Even if this doesn't solve the problem, I'm just going to leave it until I can get a cap tester and really prove that something's wrong before I start going to replace things. It might never happen again. I might never even notice it, because I mean, I'm not going to use the radio very often. But so that's everything back together there. I also finished the crossovers. So I've put the film caps in place of the old AC electrolytics. So I'm going to go install this back in the chassis and fire it up and see how it goes. So I just had one of those moments where I realized something earlier. When I was looking at the grid of the 6AQ8 before, and as I went up in frequency on the dial, I noted that the amplitude got smaller and smaller as I kept doing that. And, well, I know the answer. I know why it's doing that, and it's not the radio. It's sort of one of those duh moments. This is my Siglent SDS 1072 CML. When, if you notice, it only has a bandwidth of 70 megahertz. And I'm looking at signals that are greater than 70 megahertz, about 110 or so. So the attenuation is not actually the signal. It's the scope is simply we're on the decline. So yeah, that there isn't actually an issue there. I just don't have a fast enough scope. The front end. Also, when I touch the probe, that capacitively couples me into the circuit a little bit, and that at the higher frequencies is more of a challenge anyways for the circuit itself. So no, that never was an issue. In case anyone's wondering, that was just me being an idiot and not having good enough test gear. So I'm just cleaning the last thing I forgot to clean before I put this back together again, and that's the plate here. And one of the sides was completely loose. The other side still had a bit of glue left on it, but this glue is pretty rock solid, and it didn't adhere very well to the wood over the years. So because I'm just putting this back temporarily, I want to take all the electronics out when I stain the thing, just in case. So I'm not going to glue this back down. I'm just going to lay it on there, and that should be good enough until I can get around to doing the tabletop, and once I do the top, I'll probably just use some wood glue maybe. I'm not entirely sure. I want to make it so that I can take this off again without too much of a hassle. So I'm not sure what I'll use. I could even use double-sided tape, just 2 strips of double-sided tape. Something that will hold it on there so it won't move, but I can at least get it off without destroying this, because, you know, if you apply too much pressure, you'll bend this and then you'll never get it back again. So I'll probably do something like that. A weak adhesive. So this concludes the electrical part, at least for now. So everything is back together now. I've got the knobs all the way on. They cracked again. Unfortunately, the super glue was not strong enough, so I'm not really sure what I'm going to do about that. I got to redo the paint on the knobs anyway. It's not as durable as I expected. The tuning knob is starting to come off because I've been turning it so much. But everything else looks pretty nice. Of course, this is all destroyed now. It's cracked in a bunch of places, just picking it up and putting it back on there, so that'll be a thing, but of course I'll do the wheel at the same time. The top I'll probably do in about a week or so. I gotta make note that this is not an easy chassis to put back together, or to put in the cabinet. This is by far one of the most difficult things I've done in a long time, is installing this chassis. Because it's vertical, you have to hold it up while you put the screws in, and I mean, it's heavy, and you've got to hold it, and it wants to fall backwards because it's top heavy because of the transformer and everything. Yeah, if you ever do this, don't do it alone. That was not easy, and I had to do it twice, because the first time I didn't realize there's a catch. In order to avoid using screws, they have a catch at the top, which keeps it aligned with the top plate, and the only way to get it into that catch is to have it in there before the screws go in, and I had missed that, so I had to take it all apart and do it again. So aside from the fact that I almost died getting the bloody thing back together again, it's all good again. So where did my flashlight go? I'm not sure. It's missing, but I got the new crossovers in. You can kind of see it there. And its performance, I mean, it should be better now because I put all of the shielding cans back, because there were those 2 shielding cans. So, yeah.
Make you glad and okay.
Now the thing I don't think this indicator is actually aligned properly. I think it's slid on the cable, so I'm gonna have to align that with the dial indicators, because it's a little annoying that I don't know what station this is. I mean, I only know one station because they keep saying it all the bloody time, and it should be right around 96.7, but it appears up here where the 40 is, so definitely wrong. But it works. And the controls work. One of the things I noticed was when I was testing with it, before I had the knobs on, the knobs are actually not, you know, normally the shaft is got a flat spot, right? That's the key. That does not actually align with the black dots. The black dots are actually, the shaft is actually over here somewhere. So when I thought it was, you know, halfway, it was actually like there, which I think is kind of unusual, which is going to be annoying because if I have to replace these knobs, then I'm never going to get one that's got the indicator in the right spot. So I really hope the cracks don't get any worse on those. So for now, I think that's it. And I'll be back in probably 2 weeks or so with the refinishing of the top. And then assuming that the radio doesn't have any more issues, I'll just basically make a cable for the auxiliary input and it'll be done. So thanks for watching. So I've got the stereo on the tape input and I've just got it connected through a cheap USB sound card up to my laptop here, and Audacity is what I'm using here to generate some test frequencies. And I've got my scope here hooked up across the speaker on one side, and you can see so pretty low noise here, you know, 50 millivolts per division. It's very high frequency. It's actually in the megahertz, so this is probably just oscillations of some kind. And as I change the volume, that doesn't really change at all. So relatively good looking. So I'm okay with the noise floor on this. So what I'm going to do is I am going to run a test pattern. This is test signal. This is a 1 kilohertz sine wave, and you can probably hear that. So these speakers are very, very, very efficient. So the voltage you get across them is very low. So that looks pretty good. You can hear there's a bit of crackle and stuff, and you can see that it loses sync, so something is going on, but yeah, you can hear that. It's all on the right channel. Nothing on the left channel. The volume seems to change the amplitude of that noise. So it's before the volume control, and the volume control is the beginning, so I'm interested as to what that would be. I mean, there's literally like a switch and, which it's not the switch. So it's, I mean, there's just like a resistor and a capacitor before, not much. So I'll have to investigate those. Yeah, so there's one channel. I think there's a bad component in the audio there at least. But that wasn't really what I was here for. Interesting. Got some interesting spikes here. Okay. Anyway, so what I was doing... That's interesting. Okay, so what I wanted to do was, I wanted to look at low frequencies because I believe that there's a lot of distortion at the low end. So I'm going to try 60 hertz here. Okay, now I'm intrigued as to what those spikes are. because they weren't there just a few seconds ago. What the hell? That's unusual. It's not like a dirty knob. The clip's only 30 seconds, so. It's like, that's reducing the bass. It's increasing the bass. The treble doesn't do anything at these frequencies. If I adjust the amplitude, I mean, that's really loud. Let's go lower while I'm here. Let's do 30. It claims that it has a frequency response of 30 to 20 kilohertz. Okay, I mean, it's barely there. There's barely a response there, but it is there. And I mean, that actually doesn't look too bad for something that it can barely do, but let's see where the cutoff really is. Let's try right in the middle, I guess, 45 hertz. Should have got a little tripod for this, would have made this easier. Yeah, again, that's pretty much on the edge. I'd say its response is more like 60 hertz and above, but I mean, that might be the 3 dB. I haven't done the measurements. 30 might be the 3 dB point. So aside from these very strange, really, looks like really high frequency components on the signal, so there's no input anymore. So let's zoom in here. Yeah. Look at that. How fast is that? 632 hertz or so. And what's the period of this? How often are these things happening? Bring up the cursors, and we will cursor A. Let's say it's there, and B. They look very evenly spaced. So that's every 8.5 milliseconds, or 117 hertz. Interesting. I'm not sure, I mean, they're very consistent with the time. You can see that one's the trigger, so that one's locked, and that one's really not moving much. That's weird. And the input signal doesn't change it, the volume doesn't change it. Let's switch to AM, no, FM. Oh no, sorry, that's tape, then it goes phono, then it goes AM, then FM, and then FM stereo. So they're not going away. So yeah, and the bass control does nothing, treble control does nothing, so I don't think it's a control. So we have some interesting behavior in that circuit. So when I take it apart next time, I'm going to have to investigate this, see if I can trace it down. I mean, it's all together now. It's all back in there, and there's a metal plate on the other side, so I can't probe anything. But it should be very easy because the amplifier in this is extremely simple because it's got the 6GW8s, which, I mean, they're basically an all-in-one integrated amplifier tube. They've got the preamp and the power amp all in one tube, and the number of passives that are around it are super, super small. So the amp is going to be very easy because we're not dealing with RF anymore. It's going to be very easy to diagnose any issues. So yeah, we're not done with the electrics yet because this is there is a distortion issue, and whether this is part of it or not, I really don't know. But I definitely want to fix this because these are pretty high amplitude when you consider the signal is sometimes, in fact most of the time, less than that amplitude. That's kind of worrying to me. So when I get to it, I will investigate this. So what I've done is I've got it hooked up now to the other channel. So that was the left channel before. Now I'm looking at the right channel, and you'll notice the right channel doesn't have any of those spikes on it whatsoever. And if I play a signal through it, it looks very clean. No issues whatsoever. This is a 60 Hertz tone. No issues at the low frequency whatsoever. And let's move up to the high frequency. Let's go to an actual high frequency now. Let's look at, I don't know, 17,000 Hertz. I probably can't hear that, so it should be easy to do. Yeah, I don't think I can hear that. And that looks very good. It looks very good. There is a hissing sound, and it's definitely not the 17 kilohertz. So that the right channel doesn't have those weird spikes, but it has a constant static issue. And the left channel doesn't have a static issue, but it has weird spikes. So both channels have different issues, and I'll have to get to both of them at some point. Because now, just so that you can see, if I switch over to the right channel here, or the left channel, sorry. I can get my little probe to stick on there. A little hook on it and everything's too big. Okay. So this is the left channel, and there's no more spikes. So, I mean, I'm really kind of at a loss here. So there's the 17 kilohertz, which looks fine. So yeah, that's strange. Because all I've done is changed where I'm probing. Let me move the probes from the connector to the speaker, which is where I used to be. See if they're back. Oh, look at that. It's back. Look at that. The spikes are back. So all I changed was I was probing on the actual speaker terminals, and now I'm probing on the remote terminals, which basically the speaker just the signal comes through this loom here in through these switches, which work exactly the same way as the tape input switch, where they've got the two wipers, and then if you don't have anything plugged in here, they just go straight to the speaker. So I mean, the only difference between here and on the speaker is about a foot of wire. So that's unusual. So this is probably just ringing, probably due to the impedance of either the lead or this cable. So this probably does not exist under normal operation, and in fact it almost certainly doesn't exist under normal operation. So that I've already disproved. So we really only do have one issue, and that's the static issue, which is definitely still there. Although I would like to know why there's distortion in the audio. I'm gonna have to find a way that I can make a complex signal and pass it into this and see if I can see any differences, because there is definitely something funky going on, because the bass really doesn't sound very good. It's possible I have a microphonic tube. That's possible, but I feel like I would have found that by now. In fact, I can actually disprove that right now by banging on the tubes with something, and that should prove that. I mean, yeah, no, they're not microphonic. I mean, there's only 2 tubes, so that's not it. So yeah, I'm gonna have to do more investigating with the scope, but yeah, the electrics are not done. We have issues with the amplifier, but at least they'll be easy to fix. At least I say that now. I've just noticed another thing with the hissing on the right channel. It actually, not only does it depend on volume, obviously with the volume all the way down, there's no hissing. You bring the volume up and the hissing starts, and it gets louder as you bring the volume up. But then if you keep increasing the volume, it stops. So it only hisses with the volume between a certain point and another point. So that leads me to believe that there's some kind of an oscillation that's probably going on the input, and that's what's causing the hissing noise, because it's a pretty consistent frequency, or at least it sounds consistent. So yeah, I'd bet that there's an oscillation that's going on, probably due to a bad component, because it's not happening on the other channel. So yeah, it's definitely an oscillation of some kind.